Hi everybody. Welcome to part 4 of the Python exercises. It might seem like we are finishing up the code today, except that we're going to come back and do some revisits on this. What are things that we could do better? What kind of visualization can we produce, and so on. But today, I really think it's valuable for us to spend a little time on some shortcuts. We're going to start with a discussion of how we can get past one of the most obnoxious things about the Python installer, which is having to find the Python exe every time. And so we will be adding Python exe to the directory in which it sits to our path. I'll try to explain what that means. Secondly, we're going to work on exceptions. These are particularly a big issue when we're dealing with file accesses. So I'll try to give some examples of how that can play out. And finally, we're going to look at an object type called a collection. We're going to use this because we're going to be computing how many times each letter appears in our sequences. So I would start by asking how many people have heard of a path? Path. A few people have. That's good. That's good. All right. Well, over time, how we set a path has changed. The path is the list of directories in which the computer will search when you give it a command to run. So if you run something like fdisk or some other key system tool, it will be found by the operating system because it's in one of the path directories. It's installed along with your operating system. But we didn't install Python when we installed Windows 10 on these computers. We installed Python much, much later. And Python does not by default add itself to the path. So today we're going to fix that, and as a result, it should become a whole lot easier to run these tools on these program versions on the command line. So why don't we start there? I would start by noting that if you modify the path too much, you can do some pretty grisly things to your computer. So take some care in doing this. Next, I would say that if you're working on a Macintosh or if you're working in Linux, this is going to be different. And I'm only going to demonstrate the Windows side of this. So if you're running Windows, you're in luck. If you're not, maybe look on a Windows computer for the next few minutes. Okay, so the path is something that we can find on the command line, but I think it's actually going to be easiest if we modify that path in via Windows Explorer instead. So here I'm just looking at the directory of all the files I have in Sun Python right now. I realize your list might look a little different because you don't have all these zip files and stuff piled up in there, but not going to matter too much. Instead, we're going to right-click on this PC. Are you able to find that on the left side? We're going to right-click on it. So you should get a little menu like this. Is everyone seeing something like that? That's good news. All right, and now click Properties. Okay, hopefully you got a screen that looks something like this. I'm sure some folks are not running Windows 10, maybe you're running Windows 8 instead, but hopefully things are going to look quite similar. Most people are seeing something looking like this. Good news, good news. Okay, we are going into by the way, this is one of the fastest ways to learn how much RAM you've got on a computer or which CPU it's running, but a lot of people don't know how to get to System Control Panel that quickly. So you can just do that by right-clicking on My Computer. Did I see a question? Oh, okay. Just a stretch. Oh, yes, I bought this one because it had 12 gigs of RAM. I just thought to myself, how can I pass that up? So, yeah, this little machine was refurbed, and I just bought it when I was in the States one year. Okay, we're going to go to the Advanced System Settings. You'll note that has a little yellow and blue shield by it. That's Windows' little clue to you that don't mess with this unless you know what you're doing. But today, you know what you're doing. So, click Advanced Systems Settings. Did anyone get a major error when they tried that? It's good news. Most people should have been empowered on that score. If you're on the advanced, well, you might start on the computer name tab or the hardware tab or whatever. The one we care about is advanced. Down near the bottom of that, you should see environment variables. Maybe if you're running Windows 7 or Windows 8, that could be different. But hopefully, you have something that looks like environment variables. All good so far? Okay, I'm going to click on that. Okay, now we have a series of system variables down here at the bottom, And you can see that path is there, right? We have all of these things that have already been added to the path. And then we have the things that have been added to path just for me, right? So this is Windows is a multi-user operating system. And so it might be that my wife is logging into my laptop or that I am. In this case, my user account is set up so that I have things like NCBI blast on my command line. It's not likely you have that installed on your laptop unless you've done some other demonstrations with me. But path is right here, and I want to modify the path for my user account. So I'm going to click on that and then specify edit. Now that interface may look a little different. I seem to recall in Windows 7 it has a rather different look to it. But hopefully things are not going to be entirely different and you can figure out how to muddle through even if you have an older version of the operating system. So I click on edit and you can see that in this case the software is listing off directory after directory here. If you have an older user interface, an older version of Windows, it may be giving you a directory followed by a semicolon, followed by a directory, followed by a semicolon, followed by another directory, and so on. So that's a delimited list. The semicolon says this symbol separates the last directory from the next one. So if you want to add another directory, just stick on a semicolon on the end. Don't erase what's there. Just add a semicolon on the end and then add the directory. But for now, I want to remind you that we still have to figure out where Python is located on our machines. This hopefully will be the last time we have to do this. So I'm going to click on my Start menu, type Python. Oh, I'm doing well. I can spell it today. That's a plus. Okay, and I'm going to open its file location. And we see that we have a shortcut here. Again, I'm going to ask about its file location. I think many of you may have already grown so tired of having to dig this thing up every day that you've added it to path yourself. But today we're going to just get it set up for everybody. So here's Python exe, but we're not going to grab Python exe itself. What we care about is the directory in which it's located. So remember it was in my case, C users dtab app data local programs Python 37. Yours should be located somewhere like that. So in just clicking, you'll note that when I was just looking at the directory, I saw folders inside folders at the top. If I click on that line, it changes into text. Did you see that? Okay, so now I'm going to right-click that text and copy it to the clipboard. Now I can come back over here to my path editor and specify that I have a new element for my path listing. So I click New, and it asks me to type that in. Because I'm a lazy programmer, I put it on the clipboard, and I also don't trust my typing. It's Friday afternoon, and instead I'm going to just paste that right in there. Grand. So now I can say OK, and OK, and OK some more. Why not? All right. So that's it. We've added that directory to our path, and now ideally, we need to launch a new command prompt. If you had a command prompt already open, close that one down, because it's only after we have modified the path that we can open a command prompt and have that take effect. So if I start my command prompt again, we can do a very quick test of that. Let me see, can you see my fonts? I'm going to change to a really huge font again. All right, can we pull that door back there? Thank you. All right, Consolus 28 point font. It's sort of visible. We'll be all right? Okay, so let me just try, we'll do the acid test. We'll simply write Python. Do you get the software to start? That is good news. Okay, so you're not going to have to do all that open file location business anymore. I probably should have done this on the first day, but frankly, I was worried that it was going to be too messy to do that. But you guys held on. Really well done. Okay, so I'm going to exit out of Python because I don't actually want to be running inside the interpreter. But I do want to move to the directory that contains our source code. And that on here is to type cd/sunpython. Where you've placed it may be different. Hopefully it's still easy to get to. All right. So we could try that we can run Python and hand it goal 3 by typing 209.0517 goal 3 pi. That's the version of the software that we're looking at today. We haven't made huge changes, but it's I wanted to make sure that everybody can run that and get FASTA Sniffer version 0.3 to run. All doing okay? Okay. I wanted to remind you that when you try to run this software, there's a variety of possible mistakes that could take place. So if we simply start by running the software, Python, goal3, blah, 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 and give it a farcical FASTA name. So I'll call mine farcical.fasta. Okay, so we note that we didn't have a file called farcical FASTA in there. I never gave you a sequence database by that name, right? So we just tried to run our software to sniff a FASTA file that doesn't exist. But I wanted to note that at the bottom, what we've seen instead of, I believe we tried this on Wednesday, and the software barfed and gave us a big traceback error and an exception object. Instead, today, we see that the software is reporting a relatively friendly message, error. We experienced an error opening the file. Now, it's not very descriptive, right? It could be a clearer one like, there is no file by that name, for example. That would be a better error. But what we see is that the user is protected from seeing a raw Python error message and is instead given a friendly one. So how did that happen? The answer lies in exceptions. Exceptions. So I'm going to move over to Emacs here, and now I'm looking at the source code that we provided today. Later on this will be important. I want to note we have a second import line up at the top that says import collections. That's not involved with the exceptions piece, but it's important to know about. All right, so I've made just one change in order to give us a friendly error. So what you should see on screen, I'm sorry this is a bit of a dim projector, is that we have created a try colon and an except IOError colon. That's the big change. So an exception is something that happens when an event has taken place that the computer doesn't know how to deal with. For example, what is 5 divided by 0? From a mathematical perspective, maybe positive infinity, but maybe not. So yeah, the software, the operating system is not prepared to deal with questions that are that would puzzle philosophers. So when we give Python something like 5 divided by 0, it throws an exception. If you tell it to read a file like farcical FASTA and it doesn't exist, it throws an exception. If you tell it to look for the 15th element of a set that contains only 5, it throws an exception. So there are a great many different exceptions that are possible. I have a web page here that considers a number of them. So things like an end of file error. What if you tell the software to read another line, but it has already hit the end of the file? Something like that could produce an end of file error. What if somebody is running software, but they don't let it finish properly and they hit Control-C? You can catch that with a keyboard interrupt. What if your software is gobbling up more and more memory as it runs, and you've run out of the 12 gigs of RAM your laptop has? Well, in that case, you can get a memory error. All of these errors are things that we can trap for. What if you've written your code with a library that is fine under Windows, but deadly under Linux? It has no implementation for some of its functions in Linux. That's a platform error. Things like that can be caught here. Operating system errors, overflow errors. So what if you are trying to record a number in 1 byte, an integer in 1 byte, and you've gone from 0 to 255 in an unsigned integer, and now you try to go to 256. Well, you can't store that in 1 byte. So things like that could lead to these types of errors. So we have the ability to catch these. If you recall, on our very first day, we looked at a slide that represented our path through this software. I'm going to go ahead and just open that up on screen. So you can remember that we had a decision we wanted to make. Is the FASTA file readable? If it is, then we can go ahead and just do what we do. If it isn't, we need to be able to report that error. So in this case, we are handling that as an exception catch. We're trying the process of opening the file. If it fails for any reason, we're going to catch that exception. Now, I'm going to give you a difficult question. Is the file's absence the only thing that could cause that file not to be openable? It's not. So we've told the software to open this as a text file. What if you've told it to treat as a FASTA file a JPEG that you downloaded from the network? Well, a JPEG is not a text file, so treating it as one would be really bogus, and the software would catch that as an error. What if Andreas has copied a FASTA file onto the server in his own user account, and I've tried to read it as my own account? Well, I don't have permissions to read that file. That too would throw an exception. So there are lots of ways that the file might be physically present and yet cause an error. You know, it is possible in Windows to change the permissions on these files pretty easily. See, I can right-click this, go to Properties, and then there's the security page. Now, a lot of you have probably never messed with something on the security page, but there are certain circumstances under which it's very helpful to do so. So if I were to edit the permissions on this FASTA file to specify that I am denying read and execute privileges on it, first off, Windows asks, are you absolutely sure you want to do something as boneheaded as that? But I do. So now if I tell it to run on the Mycobacterium tuberculosis FASTA file, we experienced an error opening the file. It's not an error that only results from the absence of that file. So I'm going to come back in here and correct that before I forget, because then I would be spending an hour trying to figure out, why can't I read this file? All right, so I come into security, I click that, I uncheck these two properties, resave it. Okay, so exceptions are important. Using try and except around them is appropriate. So I haven't told you quite everything you would like to know about how to capture exceptions well. We might start with, why did I put try here and why did I put except there? It is possible to put a try all the way at the beginning of your software and an except all the way at the bottom, where it allows any file exception encountered anywhere in the code to trigger whatever happens at the very bottom. That is not, however, very nice practice. Generally speaking, you might imagine that if you keep working away at this tool for a couple weeks, maybe you have a part that maybe you eventually develop the ability to read multiple FASTA files, right? The user says, run FASTA Sniffer on all FASTAs in this directory, and then the software then cycles through each FASTA to make its report about it. But only one of those FASTA files has an error in it. You see the problem now. Our exception doesn't know that, that this problem has only happened in the last case. So it's better in this case to have sort of a nice contained exercise. There is one particular function here that that is likely to create an IO error. If at a later time we were trying to write the statistics to a file, that would be a different case, right? I mean, we're opening an output file, so having another try and except around that would be appropriate. There might be a section that deals with some thorny math, so you might put a try and except block around that to check for things like division by 0 or someone taking the logarithm of a negative number. So lots of circumstances under which try and except will give you a bit of help. I first learned about exceptions when I was working in Java, which has a very mature structure for how to deal with exceptions. Okay, and I would note that once again, I've thrown a quit command in here. So I've said that if there's a problem opening this file, everybody jumps out of the pool. This is the end of execution. We're not going to try anything else if that file cannot be read. So I tossed a quit in there. All right. Now, as I mentioned, we were going to, are there questions about exceptions before we move ahead? Okay. Again, this is a way to protect your user from seeing a big, ugly error message when they could get one that you've written to provide. You know, we could write some suggestions here, like, unfortunately, we couldn't read this FASTA file. Have you tried checking to make sure that the file name you provided is actually present? Are you sure you have permissions to read that file? That's the kind of advice you can give the user when you do an exceptional catch. Okay, great. Now, I already told you that we were adding another import to this. And just for the record, if you try to import a library that is not installed on your user's computer, you can also try and accept that to say, hey, you need to install so-and-so. So again, this is politeness. Politeness goes a long way towards somebody who's encountering your software for the first time, coming up to speed and how to use it. All right, so we've now imported collections. When I first started creating this project, I thought that it would really be best to teach you about arrays. And I thought, okay, we'll make an array that has every letter represented by some value in that array. So if there's an A, maybe we'll add a count to the first one. And if there's a B, well, you shouldn't have a B in amino acids. You can increase the second one or the third one, the fourth one, whatever. There are no arrays, per se, in Python. Arrays can cause a lot of grief for people. So we might imagine, for example, if you have a string, strings are kind of like arrays, right? So you might have a string that has only 5 letters in it and ask that string to give you the 7th letter. See why that would be a problem? You'd raise an exception for something like that. So arrays don't really exist here, and arrays can cause a lot of problems in their implementations. Instead, we're going to use a data structure that is included in Python called a collection. And that collection is a really useful structure. So here we import the ability to use those. And down here at the bottom, we have some new code. First off, we want to create a collection. So we're using a constructor here that creates a counter, which is a type of collection. So many people, I think, here have worked with R, correct? Do you remember factors? Does anyone remember factors? No one remembers factors at all. Well, this is bad news. Has anyone ever written a factor in R? Oh my goodness. All right, well, let me give the most common example of a factor in a clinical data set. Generally speaking, if you're doing a clinical study, you like to know who of your participants is of each sex, right? So you might write male, male, female, 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 male, male, female, female for a column in a big spreadsheet. That is a great example of a factor. In this case, we have relatively small numbers of different values that are possible, and we're just making sure that one of those values appears for each person, right? So what happens if you're working with a table that a sleepy grad student produced in another laboratory, right? You've inherited these data, and you've got to make them sing for your project. So you've now read that into R, and when you look at the column for sex, you find that you have 4 different values. You have a lowercase m, an uppercase m, a lowercase f, and an uppercase f. Well, this happens, right? We're sleepy, we make typographic errors, and suddenly we have more than 2 values for sex. That is an awkward kind of position to be in. So a factor lets you see all of the different values used for a given column. So that's a factor. Or you could think about different fruits found in the fruit bowl this week. Well, there are bananas, pears, apples, apples, apples. That would be 3 distinct values with 5 total instances, you see? Okay, factors. If you have experience in the language Perl, you may have used something like a hash. And when you use a hash, the software is able to record every time multiple rows use the same language for something. So you might have 100 items, and the hash helps you recall that there are only 70 different values taken from those 100 columns. So the same concept shows up in lots of different languages. So here we're creating something called letter counts, and it is a counter from the collections. We've added a bit of code in here. I think you recall that when we were looking at our code Wednesday, we wanted to check the first character of the line read from the file. And here you can see that we check to see, is that equal to a greater than symbol? Everyone remembers equals equals? Why that's different than single equals. I know that one is frustrating. Okay, so in this case, we're checking to see if it is a greater than symbol. What I've added this time is an else to this, you see? So if the line represents an accession, we're going to say it's a new accession. If it's not a new accession, we're going to say this is a sequence line. Now, I've done something kind of dire in a way. I'm going to move up a line of text on screen. Okay, well, all right. We have a for loop that is treating each line from the FASTA file as a different thing, right? So we have line 1, then we're going to move to line 2, then we're going to move to line 3. So remember that we said that this is the software thinking of the text file as a sequence of lines. In the same way, we're going to run another loop where we loop through the characters of this line. So what we have is what's called a nested for loop, a nested for loop. You can sometimes see these called in structures like nested ifs. What it means is that we have a for loop running inside another for loop. So that might seem a little bizarre, but in fact in programming you end up using structures like this all the time. So what I want you to think about is that for the first value of the for loop, we're going to grab out a line that's got a greater than symbol. We allow the accessions count to go up by 1. Then we read the second line. In the second line, we see that there's no greater than symbol, which means it's a line of sequence. Okay? So this second for loop operates within this particular instance of that first for loop. And it's going to say, all right, I'm going to look at the first character, the second character, the third character, the fourth character, and it's going to keep going until there are no more characters. What it's going to do for each character is dump it in the bin. You see this? Letter counts update. So letter counts was created up here. We created it as a counter type. And here, we're going to dump one letter of sequence into it. Right there it is. So if you imagine that you have a FASTA database where 60 letters are on this line, the second for loop is going to dump the first letter, the second letter, the third letter, all the way up to 60 for that line. And when it's done, it's going to hand control right back to the outer loop. So we have a loop within a loop. It's a little bizarre, but it's how we think about it. So one loop goes from line to line in the bigger file. The second loop says each character in a given line. All okay so far? Okay. I hope it's useful to talk about how programmers think about this, because it's it can seem a little confusing that you would put one loop inside another. Okay. Now, one of the very special things that's going on here is a bit of magic built into the counter type. So our letter counts, remember, was a counter from the collection family, and update has it compare this new letter you're handing it to all the letters it's looked at before. So when we created the object, it started with nothing in it. It had no letters in a hopper. You didn't know whether it was going to be integers, integers, floating point numbers, Boolean values, letters. In this case, we feed it letters, but we don't even have to tell it that in advance. So that's very handy. All right. So this update process has the software ask, have I seen an object like this before? What we're passing it is an individual letter. Remember that this is which letter is being passed to it by this for statement. So that letter is could be the first time it has seen the letter capital A. It could be the first time it has seen the letter capital C. So it's going to add that to its inventory of things I've seen and say its count is now 1. But the second time you hand it the letter C, it says, now hold on a second, I've seen a C before. I don't have to add this as another type of thing. I just need to increase the count associated with the letter C. So that's the bit of magic. Update is handling all of that for us. And because we have an object that's so well attuned to our purposes, we don't have to create it ourselves. All right. Now, I've changed the report session down here a little bit as well. You see that letter counts, this count object, is able to print its own contents if we simply run print around it. So let us now, let's go ahead and just run the code as it is here. Python goal 3, and then the whole Mycobacterium database. What do you think? Is this a complex operation to ask a modern laptop to do? Not really. Not really. Sniffing through this file does not take a huge amount of time at all. See, that was probably, what, 3-4 seconds? Maybe it was less than that. So the software knows that this is the sequence database it's supposed to work with because that was handed to it on the command line. It's able to compute the count, 4,018 sequences. That hasn't changed a bit since what we did on Wednesday. And the software is able to output the letter counts because we told it to just print the contents of counter. Now, counter is not pretty, is it? If you just tell it to output whatever the object counter is, we could argue that this is a pretty ugly way to do it. I mean, you might like a table, right? What if you were going to grab this text and shove it into Excel? Wouldn't you rather that it said a nice column of A, G, L, V, blah, 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 and a bunch of accounts beside it? That'd be a lot nicer. So right now, we're just using the default count output. As we move ahead on Monday, our goal is to make this a whole lot prettier and easier to use. And maybe, if I'm incredibly crafty, we'll get a graphic out of it. That would be even nicer, because after all, who doesn't like another figure for the paper? So this is what we're attempting to do today. And as we see, the code is not that difficult to get from where we were on Wednesday to here. I think it would be useful, though, if we spend a little time working with the count object. So you can see in our code that letter counts is created right here. So I want to just run Python in interactive mode. So I'm going to just type Python and hit enter. So here we are in our new code. So I want my, I'm going to call my thing my counts. My counts equal collections. This isn't going to work, by the way. Collections.Counter. Okay, what happened? Why didn't that just run as is? Does Python know what collections is? It does not. Right, so if we come back to our code and look at the top, we remembered, oh yeah, in order to get access to the collections object, I need to first tell the software to import that library. So right-click that. There we go. Import collections, that's run. Now I'm going to back up and retry my counts collections.Counter. Should get nothing back. The software hasn't done anything yet. So if you print my counts, you get a pretty empty list back, right? It just says I'm a counter. That's all I know. Did anyone watch Sesame Street? Does everyone remember a purple vampire who got really excited about numbers? Yeah, that's who my counts is at the moment. So, all right. Was his name just the Count? Am I remembering that correctly? The Count. I like that. All right. Well, my counts is going to get updated here. So my counts dot update Let's use the example of a column giving the sex of subjects in a research study. So I'm going to say update it with M. Now I'm going to reprint it. See, now it knows it has a type of thing to count, and it says it's an M. Let's add a woman to the study here. Oh, there we go. Update with an F. Now it says that there's one male, one female in the study. I'm going to give it a third value, another M, but then we realize we've gotten our sex balance out of way, so I'm going to add two Fs after that. Okay, now let's print our my counts. Great. So here we see that the software has successfully detected that those three M's were all the same type of thing. They were identical. So it's able to count that so far it's been updated with 3 M's and 3 F's. Okay, let us now see what happens if we forget that we're being very brief in our table. So we're going to add female and add male. You see what a disaster we just caused ourselves? So my counts had decided that the kind of thing it was counting was individual letters. But we passed it a whole string. And now we have this huge number of items that were created by adding an individual word at a time. So one of the things that we might have done is to pass my counts an entire line of sequence at a time and had it break it up into individual letters. Personally, I think that would be a little more confusing in the code, though. So maybe it's better to have just handed it one letter at a time. Okay, now let's try starting my counts over again. I'm going to back up to just create it afresh. All right, so I've emptied out my counts. It's got nothing in it. Print my counts, I get counter, nothing. Great. Let us start by adding, by trying to put the whole word male in there at the same time. When I try to print that value, okay. So we see that counter is not going to give us how many different strings are present. At least in this default behavior, it's willing to treat each character as a different thing, but not to deal with whole strings. There are probably things that we can use like that, like to give us a factor-like behavior in R. That's good to know. All right, now I'm going to clear it away again. Can we use my counts, this collection, to handle numbers? So my counts update with the number 73. It's my lucky number. Oh, look at that. So it doesn't like that one. So it may be that collections is a little particular in what kinds of things it likes to count. Darren, can you give us any thoughts on why the software is being particular about wanting to handle each letter separately? You don't use collections. He doesn't use collections. Okay, so maybe it's built into every Python install. Yeah. Okay, sorry. Well, we can always check the documentation. Now, can I do that from inside here? I can't do it inside here. So, happily, when I type Python in, I see that I have manuals. So if I open the manuals, I get a Windows help file, believe it or not. Haven't seen one of those in a while. I'm going to run a search, and I'm going to look for collections. Woof! Somebody didn't like that. All right, that's an abstract base class for containers. Collections module offers the following abstract base classes. Where's the counter in here? So would you say that... Oh, is the... It's having a little freak out at that? All right. I'm going to see if I can find a counter instead. That was the name, correct? Yeah, counter. It chimes every time I do that. That's just really irritating. What a terrible search function. All right. When in doubt, we spend our fine time over on the web. So let's see. Collections.Counter. Which one? Yeah, collections.Counter. Python. It's the Python module of the week from March 16th. Wow. A counter is a container that keeps track of how many times equivalent values are added. Yep. Bag or multi-set data structures. Counters, blah, 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 blah. Okay. All right. Well, you can see that there's a lot of help out there. And this is the sort of thing where having an experienced Python buddy around is very, very good. Okay. Let's see. What else do I want to address with these? No, I think that's most everything. So make sure we quit out of here successfully. Quit with open and close parentheses, and you should be back here. All right. So that really brings us to the end of today. We will be back in here on Monday and Wednesday of next week. But as of Wednesday of next week, we are all done. This is a really fast introduction to programming. So if you have particular questions you'd like to raise about how to write a thing, I'd be glad to help you with that. So if you'd like to bring a potential description of, I need a tool that does X to class, we can help brainstorm quick ways to get to an answer that could help solve the programming challenge you're looking at. Okay, so with that said, have a brilliant weekend, and I will see you all on Monday at 3. Thanks.